Hi, and welcome. This is part one on what promises to be an epic journey, many parts. I am attempting to make my own 6x48 belt sander. And the first step is I want to make drums, and I need to be able to turn them out of this material. But I need to be able to hold it to work on because I need to bore some of the inside. I need to put slope on the outside, relief on the outside. So I need to make a mandrel, and I'm going to make a mandrel in 3 pieces as you see here. And it consists of a wedge, an expanding portion, and a base portion that will mount in the vise jaws. And you might wonder, why didn't I just make 2 parts? And that's because in order to get back here to do this relief right here, I need to make it into 3 pieces so I can get a tool back in here, because I don't have anything long enough to get in the front, from the front side and still cut this out. So first step, we're going to make a mandrel, and we're going to make the centerpiece out of steel, and I think I have some 12L14. Never worked with it before, so that should be fun. The remaining 2 parts are going to be made out of aluminum because they don't need to work for hundreds of parts or even dozens of parts. I only need to hold 2 of these guys, so that's where we're headed. So next step, we're headed over to the lathe, and we're going to turn some of the easier parts. And this bottom section is threaded. The top section will have a cap bolt that fits through it, and it'll pull these 2 pieces together, and this will expand. I don't have it shown on the drawing here, but I am going to cut some slits in this. All right, let's move over to the lathe and get started. Remember when I was talking about the saw paying for itself? I'm going to have to cut this piece twice. This would be $10 a cut, so here's $20 right off the bat. And the end of the cut. Look at that cut. That's a beautiful cut, right? Pretty darn nice. A little bit of striation, but pretty darn straight. All right, first step, face. Next up, we're going to take longitudinal material off, and we're going to go back a total of 2.625 inches. I'll put a witness mark here so that I can see where I want to end up. We got to take off a fair amount of material, so we're going to go for 75 thousandths first pass. So to see if I can get the chip breaker to engage, I'm going to up the feed rate significantly. So we're going to go for 9 thousandths a revolution. This is going to be moving pretty quickly because we're at 1100 RPM, 1120. Oh yeah, now it's breaking chips. Nope, same thing. All right, so I'm going to throw a chamfer on this real quick just so I can test, put my test piece on here, because that's really what's important. Okay, I guess we're going to call that good. That's really tight, and that's what we wanted. So I got the depth of my piece wrong. It's supposed to be 2.625. I had it 1.625, so I had to go in an extra inch. But now we're right there. And now I need to take the outer 6/10, and I need to take that down to 2-inch diameter. So I'm going to put a witness mark here at 0.6. We actually need to go in a full 2 inches, so this is going to be crazy. Taking 100,000 passes. Those chips are kind of hot. We're going to go a thousandths over on purpose so that I can make this slip over easier. And I got to go to the final 0.6. Undercut. I actually explained this wrong before. So what I've done is, this part is just material to hold this while I'm machining it. I'm going to cut it off right where this line is here. So when this is mounted in the jaws, 1.6 inches of this will be beneath the jaws, and 1 inch of it will be exposed, which will leave about 0.4 inches of this section here. And this will mate up with the next piece that is the spreading piece, and the wedge will drive right down the middle. So we're getting ready here to drill and tap for 3/8/16, and we're going to start off with a center drill. All right, next up, I'm going to take a parting tool and I'm going to cut in as far as I can, which isn't very far. I can't part this off. It's 3¼ inches diameter. This will part maybe a 2-inch diameter part max. Actually, I think it's a little bit less than that. So what I'm going to do is I'm basically put a groove for me to take over to the bandsaw, and that'll make it easier to cut off. Then I'll bring it back here and face it off. First part done, 2 to go. Next part fits over the last part, slides over right here, and then the wedge comes in from this side and squeezes both of them together while spreading this one out. So we've got some material loaded. We need to face it and reduce it down to 3 inches back, a total of 3.413 inches. Alrighty. So we need a 1/4 inch off of this to 100,000 pass. Another 100,000 pass. So again, the fit is really tight, and I left purposely like 2/1000ths, although I can't feel quite 2/1000ths. That is really good, snug. The ends, well, it's not perfectly round inside, so that's part of it. But yeah, there's a little bit of slop. I left 2/1000ths because remember, this is going to expand to grab, so I'm counting on it. Anyways, I think this should work right. If I really wanted to be accurate, I would get an expanding mandrel that would expand from both sides, because right now this is going to pull tight just on the front side, which will let the back move ever so slightly. So if I want real precision, this is not the kind of mandrel to make. But I think it'll be more than adequate for this job. So let's proceed. So now we're going to drill, and we're going to go up to 3/4 of an inch and go all the way down to the bottom, which is all the way through. The final diameter is 0.8 something, but this will remove most of the material. So next up, we've got the through hole. Now we need to do 2 inches down 1.175 inches. And so I figure why not use a drill bit for part of that? We'll make it a lot easier on ourselves. Some boring time. This is a 1 1/8 drill bit. This will save me a little bit of boring time. Now we're just boring out the inside. We got to get to 2 inches, so we got a fair way to go. And I don't know how aggressive we can get. Let's try this one. It's about 50 thousandths. This is a solid carbide boring bar, 1 inch. This is about 100 thousandths depth of cut. Oh, I'm sorry, 150 thousandths total depth of cut, 75 thousandths a side. Alright, I thought it was clear, but it bottomed out. Oh, boy, that's a piston fit. Nice. Okay. There you go. So now we just need to do in the back 1/4 inch, we need to do a relief 1/4 inch deeper to make it thinner, easier to bend. Let's see if I've got the tool. So we're going to try an internal groove here. Alright, so we finished this side, and the relief is better than I thought. I was able to get it even a little bit deeper, which is what I wanted. I didn't even know if I get the 1/4 because you want this to be able to flex. So that's good. So now we're going to take this part out of here, we're going to cut it off, and we're going to flip it over, and we're going to do the bevel. And we'll be nearly done. Then we just have to make the wedge to go in. So I parted this guy off, and I sawed just the edge, and it's amazingly accurate cut on the saw, so I can just face off that 20 or 30 thousandths, whatever that is. And of course I had to drop it and put a ding in it. That's just me, Claude. So we're going to mount this way, and then we're going to put a taper in this side. Working on this guy, I have to put it in the four-jaw chuck, but I don't want to damage the surface finish. So I have an extra piece of this stuff, and what I'm going to do is I'm going to cut it in half, and I'm going to take about a 1.5 inch piece off of here, and I will use this, which is what this was intended to fit into, which it fits very nicely, and I'll use this as a jaw protector in the four-jaw vise. So I've got my part protection here, good 1/2 inch thick piece, so should minimize deformation and scratching. It might scratch a little bit, but no big jaw marks in it, so that's good. And we just need to remove this little lip here, and we'll be good to go. So we're looking to bore a 15-degree hole here going in. And in order to do that, I've set my compound at 15 degrees, locked it off. To set it as closely as possible, I've got a 15-degree angle block attached by magnets, basically iterated back and forth until just about no movement in the dial, a couple tenths. Oops, and now I screwed up my settings. Anyways, it was right on the money, within maybe a tenth or two, which is more than good for this. So next up, we're going to bore a hole. Alrighty, I've locked my Z-axis. I'm going to use my my cross slide to adjust how far in the cut starts, and then I'm going to use my compound to actually perform the cut. And I think we should be good to go. I've got my Z-axis locked because we don't need to change that. All right, so we are done with this part. So you can see the nice bore. So now it's pretty smooth except for in the back. I might do a really light 1/1000th pass with some lube here. Then we're going to take it over and we're going to cut it in 6 sections. Alrighty, so we got the piece we just made with the bevel inside and the relief on this side. And we need to divide this into 6 equal parts. So we can do it with a bit of geometry. So you start by drawing a diameter. So I'm scribing a diameter here. Next up, we take our calipers and we set them to half the diameter or the radius. And I take a compass and I set the 2 points on the radius width. Then what I do is I set the compass over here on the diameter and I draw a line there, and I draw a line there, and actually I could continue over on this side, and continue over on this side, and then I just need to match those points, which they do, and there we go. There we go. So now I have divided this circle equally into 6 parts. And if you wonder where I got that, Machinery's Handbook has it, telling you how to inscribe a hexagon in a circle. Pretty amazing, huh? So you can do that with dividers or some other tool, and a compass like I used here back from school days. And anyways, that'll help you divide this into 6 parts. So now I can make my 3 cuts and split this 6 ways. All right, so this guy's done, and it has a little bit of flex to it even with my hands, and it only needs to move a couple of thousandths to grip. So I think that'll be fine. So next we're going to try and use some 12L14 here, and we're going to make the slug that goes down the middle, or the wedge. And that should be interesting because I've never used 12L14, but it's supposed to machine beautifully, so let's find out. I left my compound at the same angle it was when I cut the other part, and I've just rotated my quick change tool post. So what I'm going to do is I'm going to leave my compound at this angle. I'm going to face this off. I'm going to reduce this down to the maximum dimension of the wedge. Then I'm going to cut in this way, so I know that I've got everything set the same. I'm going to also use my parting tool, and I'm going to cut a slot into the actual final depth so that we're on the same page here. So that's my plan anyways, and I think it should work. Let's just give it a try. Put a new tip on the cutter. We're going to try a 25 thousandths depth of cut. All right, so there we are to final dimension here. So now we're going to taper in this way, but first I'm going to put a relief down at this other end here so that I have somewhere to aim, and I'll go into final depth on that too. All right. And just so we have plenty of space to work with here, I am going to come in again, overlap a little bit, take it into the same 0.9. This parting tool is a Kennametal and it works really well. If I could afford all their tools, I'd buy them, but I can't. All right, so now we just cut the angle. I think this should be all right. We'll give it a shot. Okay, I think we're there. Next we're going to drill for 3/8 clearance. Next up we're going to counter bore. And sadly, the counter bore I have requires the hole to be bigger than 3/8, so I had to actually go up a full 32nd over size, which is a little disappointing. And we go in 0.375. Okie doke, here are the pieces together, and they're assembled very simply. This piece goes on top of here, this piece goes inside, and this piece gets tightened down. So I'm going to load this guy up. Let's hop over to the lathe and see if we can see this guy in action. Okay, so one more little improvement I'm going to make is when you try to eject this out of the aluminum cone, because this is not hardened steel and because it's aluminum, it tends to stick even with lubrication. So I am going to put a little indentation, a little cutout, a groove or a slot, and I'm going to put this little C-clip in there, and that, as I untighten, will mate up against this and push it out along with a washer. Okay, so it's amazing how out of round this bolt is, that it's a little bent. So my intentions here are to actually use 2 of these clips back there and a washer to help keep the part in place. So let's see how that works. So here's the mods, just a C-clip and a circlip and a washer, and as this untightens, it pushes this out. So the problem I was having is when I tightened this down, it would press the steel piece into the aluminum and probably even gall a bit, even though there is lube on the inside. But now, because I've got the circlip on the inside, when I loosen this guy, it's going to pop this piece out, and now I'll be able to get the part out without fully disassembling the whole thing like I did before. Anyways, I think that's it for this part. Thanks for watching. Hope you find it useful. Hope to see you next time.